All right, good morning, class. This is Mr. Walker coming to you with the final part of our unit. We are talking about symmetry. So, it's been a while since you've probably heard this word, but you remember it hopefully from elementary school. So, let's get into it, y'all. All right, we got two different types of symmetry that we're going to be dealing with: reflectional and rotational. So, let's first talk about reflectional symmetry. So, reflectional symmetry occurs when one half of the figure is a mirror image of the other half. Now, to couple along with this mirror image is folded over a line of symmetry. This is a line that divides the figure into two mirror images. So, we're expecting that what's ever on the left side of this will match up with what's on the right side of this line. So let's go through a look at these examples. Do these figures below have reflectional symmetry? And if so, draw the line of symmetry. So first one for A, it's a square. This definitely has reflectional symmetry. We have over here across, and we also have here down the middle. We also got diagonally. We also got the other diagonal. So this has three, one, two, three, four lines of symmetry. Now over here, we got a triangle. We want to make sure that it has a line of symmetry. This does happen to have a line of symmetry. This triangle here is an equilateral triangle. I'm eyeballing this, but I'm very certain. So we got this line of symmetry right here out of this corner. We got this line of symmetry right here out of this, and right down the middle. Now, hopefully, you're starting to develop some connections with our line of symmetry with this. So, for our final one, we got this letter N. Does this have a line of symmetry? Nah, son. See, there's no way that we can cut this N in half to where the left side and the right side or the top and the bottom will line up with each other. So, one thing I want you to recognize when it comes to reflectional symmetry is that if a shape does have a reflectional symmetry, the lines of symmetry are usually equal to the amount of corners that you have on the shape. So we have a square over here. This has four corners. This has four lines of symmetry. One across both our diagonals, one down the middle, one down the middle horizontally. Over here for the triangle, this has three corners. It has three lines of symmetry. One, two, three. Okay. If we had an octagon, that would have eight corners, eight lines of symmetry. If you had a hexagon, six corners, six lines of symmetry. All right. So that's just a good, you know, little rule that'll help you out going through this. Now, not every shape has a line of symmetry. You have to be certain about this as we go through it. Okay. So let's talk about the other type of symmetry. All right, so our other type of symmetry is rotational symmetry. So, rotational symmetry occurs when a figure is rotated around a central point less than one full turn, meaning less than 360 degrees, and the same image appears two or more times. So, if you turn a shape around and it looks the same as, it originally looked, it has rotational symmetry. Now, we have two things that go along with this: the order and the magnitude. So, first off, the order has the number of positions in which a figure looks exactly the same as you rotate the figure. So, how many positions can you turn a shape around to where it looks the same as you go through this rotation? Now, lastly, we got the magnitude. The magnitude is the measure of the angle of rotation. So as you go through your checking of if you have a rotational symmetry or not, you have to be able to tell me what is the order and how much is your magnitude. So first off, you take the full degree of our turn, which is 360. You divide this by however many positions you have that the shape looks the same, and that gives you the magnitude of our angle that we are rotating on. So let's look at our shapes from earlier and see if it has rotational symmetry or not. So first thing in our column here, does our shape have rotational symmetry? So we rotate it around, we rotate it around. Let's see that one more time. So does it have it? Yes, it does. Now, what is the order? The order is how many positions can we turn this shape? This has four sides on it, and you can continue to turn this around to where this looks the same as we go through it. Now, for our magnitude, we take our order and we divide 360 by that, and that gives us our angle of rotation, which is a 90. Now, for the next one, we got a triangle. If we rotate this around, does this look the same? Let's check it again. Yes, it does. So this does have rotational symmetry. Now, what's the order of it? There's about three different ways you could turn a triangle. So the order is three. So we're going to take 360 and divide it by 3 to get our magnitude. So 360 divided by 3 gets us 120. So this is our angle of magnitude. All right, last one we got here is our n. Now, we said our n didn't have reflectional symmetry. Does it have rotational? Let's look. All right, we're rotating it around. So does this still look like an n as we rotate it around? Yes, it does. So this right here has rotational symmetry. Now, what is the order of it? How many ways can you turn an N and it still look like an N? This can be rotated around 2 times, okay? You can look, if it looks upside down or right side up, those both look like an N. Now, we take our 2 from our order and we divide 360 by that to get the angle of magnitude. So we can figure out what it rotates around to look the same, and this time it'll be 180. So these different angles for magnitude tell you how much you can turn it by to still have that symmetry pop up. So if you made a 90-degree turn on a square, it will still look like that same square that you started off with. If you took a 120-degree turn on a triangle, your triangle will end up looking like how it did when it started off. If you take a 180-degree turn on an N, it just flips it around and it still looks like an N. So when we're looking at rotational symmetry, we want it to be able to turn back to what we started off with. Things to note is we are going to be dealing with 360 for this. This isn't a major part of our unit, so I don't want you to have to forget about this. So make sure that you just have this in mind as we're going through. All right, so let's see how many practice problems we got for this before we jump up in here. All right, we got 2 on the side, we got 2 on the bottom. Okay, so let's go through. I'm gonna give you I'll do the we do it, you're gonna do the I do it in our practice problems, and I think I'll do the bottom right practice problem for you. I don't want you to have to do the whole thing. All right, so let's go through, let's hit some practice. All right, first one we got here is triangle GHF, and it's asking us, does the figure have reflectional symmetry? And they want us to find the equations of the line of symmetry. Okay, so first off, we got a triangle here. We got to look at our triangle and assess some things. Does this triangle have any lines of symmetry that we can basically reflect over and see one side matching up with the other? If you go down the middle, this triangle does in fact have one that I can see right now. One right here. Now, does this have any other ones? I'm not entirely sure. it definitely does have one to start off with. So here's our line here. We want the equation of this line. So this is a vertical line. That means that this is x equals whatever number this is. So the equation of this line here is x equals 3. Now, are there any other lines on here that give us reflectional symmetry? Unfortunately, no. This is it looks like it's an isosceles triangle. See this side here and this side here? These are both the same size, but this side down here is short. So since this one is shorter than these two, you're not going to have any other lines of symmetry that are going to help you out with that. Okay? So when you want to go through and judge whether or not something has reflectional symmetry, you want to make sure that you're aware of, if I fold this shape over whatever the line of symmetry I have, are the corners going to line up? Will the things on the left side of my line match up with the stuff on the right side? Will the stuff on the top half match up with the bottom half? It may not. So make sure be sure of that. All right, let's go through. Let's address the bottom right one. So here's our bottom right one. It says line M here, which is this line cutting us down the middle, is a line of symmetry for our pentagon ABCDE. First question they ask is, if the measure of angle B is 117, what's the measure of E? And then for B, it says, if AB is equal to 6, CD is equal to 4, and AE is equal to 4, find the perimeter. So we got two things, kind of a doozy. So first off, let's address some stuff. We got angle D here. It says is 117. Why is angle D equal to 117? That's because it's the corresponding angle to B, because B is also 117. Now, if that's the case and those two are matching up, that means that whatever I have over here should match up with what I have over here. And we're going to have to use a little bit of know-how to go through this. So let's see what's next. All right, coming up next, we also know this other top angle is 41. We see down here on the bottom by M, this is actually a right angle, which means that this here is also a right angle on this side. Now, we know enough of the angles here to go through and get some work in. So first we got to know, what type of shape is this? This is a 1, 2, 3, 4-sided shape. We haven't dealt with a lot of quadrilaterals just yet, but quadrilaterals have 4 angles, and all 4 of those angles add up to 360. Now, this isn't something I'm going to say you should have remembered or should have known before now. We haven't necessarily talked about it, but that's why I'm going through it with you. So, all 4 of these angles add up to 360. So, I'll take these 3 that I do know and subtract them so I can find out the one I don't know, which is 112. So if I take 90, 117, and 41 and subtract it from 360, that gives me the measurement of angle E, which is 112. So the idea of this is I'm taking some information from my shape so that I can go through and build it up off of this line of symmetry. This line of symmetry lets us know which angles match up with which sides match up with which. That way I can go through and answer any questions that are involved with this, find any missing angles, missing sides, area, perimeter, all that type of stuff. All right, last one for B. We want to go through and find the perimeter for A, B, C, D, E. So first thing we got to go through and do, let's look at the stuff that we know. I know AB is 6. CD is, sorry, not CD, DE, my fault. So AB and DE, those are both going to be 6. That's because those sides match up with each other across this line of symmetry. Now, if that's the case, if CD is 4, that means that BC is also going to be 4. Now, down on the bottom, I know that that whole length from A to E is 4. And now finally, we have to find the perimeter. The perimeter of a shape is the distances added up around the shape, all added together. So 4 plus 6 plus 4 plus 4 plus 6 gives us 24. All right, folks. You're going to see the other two problems in your practice problems. So I'm going to catch you later. And I hope that you're doing good today. See ya.